Good afternoon, everyone. I am presenting our research titled Graph in as Light Language Modules for Local Resource Elder Nutrition Planning in Uganda. This project combines graph neural networks, light language modules, and knowledge graphs to solve a real public health challenge, of which these challenges are elder malnutrition, limited nutrition expertise, lack of cultural relevant dietary tools. Therefore, we designed and deployed an AI-driven assistant that understands Ugandan foods, health conditions, and nutrients. Therefore, this is the structure content of, of this project. And we begin with the introduction and related work, find the problem, explore research questions and objectives, and then introduce the system architecture and results. Therefore, this logical structure ensures clarity as we walk you through our scientific contributions. Background and introduction. Malnutrition among the elderly in Uganda and across Africa is evident in limited access to nutritious food, little understanding of dietary needs, very few nutritionists among or available to guide the elder. Therefore, there's no existing tool that maps nutritional needs, medical conditions, local food availability. And here our project attempts to fill this gap using AI that is safe, explainable, and culture grounded. Therefore, our system overview, the and this is the system overview. Some user like language modules, graph plus module, meal plan. Therefore, from here, the user may enter a question, and the question can be what meal is good for hypertension? And the language modules interprets the question and retrieves relevant knowledge. Therefore, the graph neural network may analyze or analyzes nutrition condition, food connections using the graph or using the knowledge graph. And then the system generates a personalized contextual meal plan, which is this. Therefore, this integration enables both natural language understanding and precise nutritional reasoning. Therefore, when we come to comparative analysis and existing research, the challenge or the challenges Uganda faces actually serious nutritional challenges among the elderly. We can see 28% of elderly are undernourished, 45% suffer chronic dietary or dietary related conditions, and only one nutritionist per 50,000 people in rural setting. Therefore, these statistics highlight the urgent and justify the need for an automated, accessible solution. Therefore, our data sources. So our systems relies on the following sources or where we got our data. We had or we have WHO, World Health Organization, nutrition guidelines. We have MSD, that is manual geriatric aging and medical and medications. Uganda street food data. Therefore, we also created simulated dataset to fill missing gaps. These diverse sources help model local dietary or diets as they are actually live in Uganda. Understanding the problem landscape. So, domain application problem versus computational problem. Therefore, we contrast the real world issue with the technical challenges. Under domain, we have malnutrition or elderly malnutrition in Uganda. There's lack of dietary tools, poor access to experts. And on the other side of computational problem, we have complex multi-hop reasoning, heterogeneous graph design, and need for explainability. Therefore, this shows why simple ML modules are insufficient. Building the yeah, building the hybrid system. Uh, we have research questions and research objectives. Therefore, our research questions are weak graph neural networks architecture modules, food, nutrition, condition relationships are best. How do we integrate cultural and seasonal context? What drives personalization in elderly nutrition? So these questions shape the entire scientific investigation of our research. And research objectives. Our objectives reflect the research questions. Build a knowledge graph of Ugandan foods, evaluate 90 or evaluate 9 graph neural networks architecture, create and assemble for optimal accuracy, deployed a production ready AI assistant. Therefore, this ensures both academic and practical utility. So our research contributions. So our major achievements include the first Ugandan food knowledge graph, which is 1,048 nodes and 14,359 ages. We evaluated or the evaluation of 9 graph neural networks architecture. We have a high performance example integrating deployment of multi-language AI assistant. Therefore, the system is locally relevant, scalable, and accessible. So, system architecture, as you can see, there is a system architecture with the users, the application, the back-end layer, and the data layer connected. Therefore, module architecture and mathematical foundations. We introduced the mathematical basics of graph neural networks. Use CRGN for compositional reasoning, Heck graph neural network for handling mixed node type, GAT for attention-based reasoning. Therefore, each module excels at understanding different types of relationships in nutritional data. Therefore, training pipeline, all modules follow the same standardized pipeline. As you can see, data splitting, 80% train, 10 validation, 10 testing. Um, so this really ensures fairness and recoverability across all experiments. All 9 modules evaluated. So mathematical formula or mathematical foundation. So these are the mathematical foundations. Composition reasoning graph network, 40% weight. So why CRG? Nutrition planning is compositional, e.g. rice plus beans plus peanut. So that data set description. So for our data set description, yeah, food composition, 5,006 features. We have macronutrients, energy, fiber, sources, Uganda, MOH, FAO, health condition. So these are the dataset description. These are the graphs or ED, EDE or yeah, EDA that describe these are the graphs that describe EDA, exploratory data analysis. As you can see, this is a graph that talks of data size. This one, the number of columns with missing values, food composition coloration matrix here, food prices coloration matrix, memory use, and all the rest. So still, these are the graphs that describe EDA, meal cost distribution. We have frequency here, we have the cost. So at what frequency? How frequent is it? And at what cost? Also here, food affordability categories, the count, type the food here, the number, and also the category. Does it fall under very affordable, moderate, expensive? So food abundance throughout the year. Most expensive food. So knowledge graph. These are visualizations to show the relationships and structure of the knowledge graph. So module comparison. So here, yeah, talking about convergence rate needed for to reach of initial loss. This is the loss threshold, as you can see. So these are the modules. Try to compare them. This is about training loss. So module testing system in action. So this is the module in action after testing it. So we have come to limitations. Therefore, limitation, uh, our project is only limited to small data set, which is just 5,000 Ugandan foods. Therefore, static knowledge graph, no real-time updates, inference time, limited validation with actual elder users, translation quality varies, like language and actual languages action. Therefore, expand dataset with regional. Yeah, this could be the solutions. Therefore, yeah, expand dataset with regional variations and new foods. Implement dynamic graph updates from market data IPS and the rest. So we have come to the conclusion, and to conclusion, therefore we successfully deployed fast graph neural network based nutrition system for Uganda. Therefore, assembled module achieved 0, 0.92 AUC, 15 minutes per second inference and suitable for mobile deployment. Support multiple local languages. The system actually contributes both scientifically and socially. And our future works is to expand other East African countries, is to expand our project to other East African countries, to integrate real-time market price APIs, deploy mobile app for offline usage, conduct clinical trials with health care partners, and also explore validated or yeah, expand validate learning for privacy. So therefore we have come to the final conclusion of our project presentation. Therefore, these are the references and acknowledgements. So, and we are likely, or we are so happy that to acknowledge our sources of data where we collected our data. So, Ugandan food composition tables 2019 or yeah 2019, World Health Organization Elder Nutrition Guidelines, Regional Foods Survey, technical support, and so many other sources where we got our data. Therefore, we have come to the conclusion of this presentation. So I would like to stop here. Thank you for listening to me.